When thousands of liters of wastewater plummet down a vertical stack, the falling mass creates a powerful vacuum behind it. Without a dedicated pathway for air to replace that void, the system will violently siphon the water out of every connected fixture trap. Welcome to JCB EduBuild Solutions. I am engineer James Barlow, and today we are translating the raw physics of plumbing into the exact regulatory metrics you need to pass the board exam. Our governing text is the revised National Plumbing Code of the Philippines. The foundational thesis of this code is absolute. Every single plumbing fixture trap must be protected against siphonage and backpressure. Air circulation must be guaranteed throughout the entire excreta drainage system. Memorizing paragraphs of text is an inefficient way to study for the board. We are going to use spatial mapping to anchor exact numerical values to their physical locations in the real world. We will use a fully navigable 3D building cutaway. This model will serve as our structural rulebook. Mastering the rules of venting requires managing atmospheric pressure across a complex, three-dimensional landscape. We begin at the micro level, focusing strictly on a single sink basin and its P-trap assembly. To function properly, all horizontal vent and branch vent pipes must be completely free from drops and sags. They must be graded to drip back to the drainage pipe strictly by gravity. Look at this cross-section. The connection is governed by the invert rule. The vent pipe invert must be taken off above the drainage centerline, positioned downstream of the trap it serves. Section 905.3 sets the vertical rise requirement. Unless prohibited by structural conditions, the vent must rise vertically to a point not less than 152 millimeters above the highest flood level rim of the fixture before it offsets horizontally. This 152 millimeters threshold creates an air buffer. If the drain clogs, water overflows the basin before turning the vent into a drain. Moving to section 905.5, the weir rule dictates the vent pipe opening cannot be located below the trap's weir. These exact micro-offsets form the primary defense against the hydraulic forces attempting to destroy the trap seals. We shift our spatial map downward, tracking the system from the interior walls into the buried foundation level. Above ground, the code permits a variety of standard materials for vent systems, including cast iron, copper and brass, and PVC pipes. Burying those materials in the soil changes their chemical environment, exposing certain metals to rapid degradation. Section 903.1.1 outlines a strict material prohibition. No galvanized wrought iron or galvanized steel pipe is permitted to be used underground. Those specific galvanized materials must be kept at least 15 centimeters above the ground surface. This restriction extends to buried fittings. Any galvanized malleable iron or steel fittings require a 152 millimeter clearance above the finished ground level. The code dictates material selection to provide a chemical defense against soil-driven galvanic corrosion. Scaling the system vertically, we expand our map to encompass a 15-story architectural tower. Wastewater dropping through a 10-story stack accelerates toward terminal velocity. The falling column compresses the air below it, creating extreme air pressure fluctuations at the base of the stack. To manage this, Section 907.1 mandates the 10-story rule. Any soil or waste stack extending 10 or more stories above the building drain legally requires a parallel vent stack. The parallel vent stack operates as a continuous air bypass, stabilizing the atmospheric pressure across the entire length of the vertical drop. The physical connection bridging the drainage stack to the parallel vent stack is known as the yoke vent. Returning to section 907.1, the code requires these yoke vent connections to be installed at every fifth floor level. Section 907.2 specifies the spatial placement. The yoke vent connection with the vent stack must be located no less than 1.0 meter above the floor level. The connection back to the drainage stack is made using a Y-branch fitting, placed below the fixture branch serving that specific floor. High-rise venting is an exercise in bypass engineering. Yoke vents act as the critical pressure release valves for the entire tower. We navigate to the highest point on our spatial map, the exposed roof deck where the building exhausts. Before the stack penetrates the roof, the vent through roof, or VSTR, must be increased one full pipe size above the reconnection point. Section 906.1 provides the vertical clearance metric. The stack vent must terminate vertically, extending no less than 15 centimeters above the roof, and be placed no less than 0.3 meters away from any vertical surface. Section 906.2 dictates isolation from human occupancy. A vent opening must terminate at least 3 meters laterally from, or at least 0.9 meters above, any openable window, door, air intake, or vent shaft. These combined metrics create a geometric exclusion dome around the exhaust point, isolating the area. The code generally prohibits flagpoling, which is the practice of leaving tall vent pipes unsupported in the open air. However, Section 906.4 includes an exception. If the roof deck is used for purposes other than weather protection, the vent pipe must extend to at least 2.1 meters above the roof. These strict termination codes exist to exhaust toxic and explosive sewer gases into the atmosphere without compromising the building's envelope. From the 152mm P-trap offset to the 1.0-meter high-rise yoke vent, our spatial map of a compliant drainage system is fully constructed. Board exams, however, test your knowledge of the exceptions. You must identify the specific scenarios where standard venting is not required. Per Section 902.1, vent piping may be omitted if an interceptor acts as a primary settling tank, discharging into a secondary, properly vented interceptor. Also, Section 902.2 provides a hospitality exception. Bar and soda fountain sinks don't need venting when standard installation is impossible. When invoking these exceptions, the sink must discharge by means of an approved indirect waste pipe into a floor sink or other approved receptor. Walk into the exam room with these coordinates locked in: 152 millimeters above the flood rim, 15 centimeters above ground and roof, 1.0 meter for the yoke vent, and the 3.0 meter isolation radius. I am Engineer James Below for JCB EduBuild Solutions. Successful plumbing practice begins with the disciplined spatial mapping of the code.